Hi everyone, today we're talking about comparing linear functions. As a reminder, you do not need to write down everything we cover in this video, but be sure to jot down important information and at least one example of each type of problem that we'll cover. Also remember that you can pause the video to jot down important notes, rewind to view information again, and fast forward if you think you already got it. Just be careful, make sure you don't fast forward too much that you end up missing out on something important. Let's get started then. And since we're talking about linear functions, we're just going to review, because if you're comparing two linear functions, you need to know what they're made out of. All linear functions are made out of the two very important components, which are slope and y-intercept. We have the linear equation in slope-intercept form. Remember that the M stands for slope. The acronym is, or the hint is move, M for move. How much is it moving by? Slope tells you how much x and y are changing or moving. And you can, on a graph, use rise over run or the slope formula. The b in y equals mx plus b can stand for beginning. So the y-intercept tells you the beginning or the starting point. That's going to be where it touches the y-axis. So the point is going to look like 0 for the x and y value as your y-intercept. So be sure you have this in your notes before we move on to some examples. Okay, so here is an example of a comparing linear functions question. We are given two functions. They've named them function 1 and function 2. Function 1 is defined by the equation y equals negative 2t plus 6. And function 2 is defined by line h, so it's on the graph below. They want to know which function has a more negative slope. Go ahead and pause the video and try it on your own first. Okay, so what I need to get from both of these functions is the slope and then compare them. In y equals mx plus b, the slope would be the m. So the slope for function 1 is negative 2. In function 2, the graph, the slope would be gotten by rise over run. You could also use the slope formula, but you already have a graph, so you might as well just count. And it looks like we just need two pretty points here. Looks like these are all great points. So when we draw our triangle for rise over run, we just have to make sure we're counting it correctly. This is going up one step, and it's going by ones, so it's just a positive 1. And then it's going to the left one step. Going to the left, it looks like it's going by ones as well. It's just skip counting. But each of these spaces is 1. It's going up first, so that's positive, and it's going to the left. Going to the left is negative. So the rise is positive 1, the run is negative 1. 1 divided by negative 1 is negative 1. So we're comparing negative 1 to negative 2. Which function has a more negative slope? The one that's more negative would be negative 2, because it's more on the negative side. If we look at a number line, negative 2 is more on the negative side compared to negative 1. Negative 1 is one space closer to get to the positive side. So this answer should be function 1, because its slope is negative 2, more negative compared to negative 1. So function 1 should be your answer. Okay, so knowing your y equals mx plus b from an equation and a graph is going to help you with these problems, because not every function is going to be displayed as an equation and not every function is going to be displayed as a graph. Let's try another question. All right, this question is also giving us two functions that we need to compare. Function 1 is defined by the following table, and function 2 is defined by this line. They want to know which function has a greater y-intercept. So you're going to find the y-intercept for both of them and then compare. Go ahead and pause the video and try it on your own first. All right, so our first step is to look for the y-intercepts. From a table, remember the y-intercept is going to be the one in this format. So it's going to be this one right here. Each of these are points. They're x and y pairs. So it's easily figured out in this problem. It is this one right here. So the y-intercept, the b, is equal to 3 for function 1. For function 2, we'll need to see where it intersects with the y-axis. So that'll be this point right here. It's not 4, it's not 2, it's 3. So we're comparing b equals 3 to b equals 3. It looks like they have the same y-intercept. And that is a choice. So that was correct. Both of them had the same y-intercept. They both started at 3. Now they're probably going to have different slopes. Let's go over real quick how you would find the slopes from a table. So keep in mind, like I said before, these are points. So this can become 0, 3, 1, 0, 5, -12, 8, -21. Okay, these are the x's and y's. One way you can figure out the slope is using your formula, because your slope formula, just needs the 2 of those points. So I can take, this is x1, y1, and this is x2, y2, and I can fill that out. y2 is 0, minus y1 is 3, x2 is 1, minus y1 is 0. 0 minus 3 is -3, 1 minus 0 is 1. So divide that and you get the slope equaling to -3. That's one way to figure out slope from a table. The other way you can do that is graph it. The shortcut way to use the slope formula is just to go like this. 3 minus 0 is 3. 0 minus 1 is -1. But you have to remember to go in the same direction. Okay? Don't go downwards, subtract 3 minus 0 to get 3, but then go upwards and subtract 1 minus 0 to get 1. Then you're going to get the wrong sign, right? You needed one of them to be negative. So that's a shortcut way. The top number subtracting the bottom for the y, rise over top one minus the bottom to get the run, -1. Okay, both are using the slope formula. Let's try one last problem. In this problem, also giving you 2 functions. Function 1 is defined by the equation r equals 3/4 t plus 5. If you don't like the r and the t, just change them to y equals 3/4 t plus 5. So I'll rewrite that for you. And function 2 is defined by the following table with the t and r. If you don't like that, change it to x and y. Which function has a greater y-intercept? Go ahead and pause the video and try it on your own first. Okay, so we want the greater y-intercept. So we need to find the y-intercept for both of these. This is the m. So this one right here is the b. The y-intercept for function 1 is 5. The y-intercept for function 2 is 5.25 because it's paired up with the 0 for x. So we are comparing 5 and 5.25, 5 and 25 hundredths. Greater y-intercept would belong to function 2. So that's all these questions are asking you. You're given 2 different functions written in 2 different forms, and you need to compare those linear functions. And remember, you just have 2 main components, slope and y-intercept. So you need to know how to get that information when the function is presented to you in different ways. Use your notebook if you want to review some of that information, and remember to jot down this information so you don't forget, especially with the tables, because we don't see tables enough, so every time we do see tables, people do tend to freak out. So just giving you a warning about that. These tend to confuse people, but it's really just your points laid out in a different way. So instead of in a table, it's just an X and Y point for these. Okay, let me know if you have any questions as you're working on these problems, and I'll see you in class.